Upbeat, thoughtful music begins and fades slightly into the background. Have you ever stopped to think about the ghosts we live with? Not the spooky kind, but the ghosts of extinct species. From the moment we started building cities and farming the land, we've been reshaping our planet. Today, that impact has become so massive that you hear it everywhere. Climate change, biodiversity collapse, and the terrifying idea that we might be living through a sixth mass extinction. Our planet is no stranger to do-overs. In its 4.5 billion-year history, life has been nearly wiped out 5 times. These are the big 5 mass extinctions. First, the Ordovician Silurian, a massive ice age that froze out 85% of all marine life. Then, the late Devonian, a long drawn-out affair, possibly caused by climate change and volcanoes, that took out 75% of species. Next up, the big one, the Permian Triassic, or the Great Dying. This was the worst of all. Colossal volcanic eruptions in Siberia choked the atmosphere with CO2, killing 96% of marine life and 70% of life on land. Then came the Triassic-Jurassic extinction, likely another volcanic event, which cleared the stage for the dinosaurs to take over. And finally, the one we all know, the Cretaceous-Paleogene event. That's the famous asteroid that slammed into Mexico, wiping out 76% of all species, including, of course, the non-avian dinosaurs. All of these were caused by cataclysmic natural forces. But today, a growing chorus of scientists argues that a sixth extinction is already underway. And this time, the asteroid is us. It's a powerful and frightening story. But is it true? Are we really on the brink of another planetary collapse, or is the situation, while definitely serious, more complex than the alarmist headlines suggest? This is one of the most heated debates in modern biology, and the answer might just change how you see our planet and our place on it. So let's look at the evidence. The case for the prosecution, those who say, yes, the crisis is here and now, is compelling. Their main argument is that we are blind to the true scale of the problem. Our primary tool for tracking this is the IUCN Red List of Threatened Species. It's the most complete inventory we have, but it's incredibly biased. We've assessed nearly all mammals and birds because, let's face it, we like them. They're charismatic, easy to find, and relatively simple to study. The problem: mammals and birds are just a tiny, tiny fraction of Earth's biodiversity. The real heart of life on this planet is in the invertebrates. Animals without backbones, insects, spiders, mollusks, crustaceans, they make up over 90% of all known animal species, and we've barely scratched the surface of evaluating them. Advocates for the sixth extinction theory argue that if we could actually measure the losses in these groups, the rainforest insects being wiped out by deforestation, or the freshwater mollusks dying from pollution, the extinction numbers would be astronomical. We'd be seeing a collapse that we're simply not equipped to document in real time. The canary in the coal mine for this argument is amphibians. Frogs, salamanders, and their relatives are perfect biological indicators. Their permeable skin soaks up toxins from the environment, and they're incredibly sensitive to tiny shifts in temperature and humidity. And the data here is genuinely terrifying. Scientists estimate that 1/3 or more of all known amphibian species are at risk of extinction. In some tropical areas, entire species are being wiped out by a fungal disease that we, humans, helped spread across the globe. For many biologists, this isn't just a warning sign, it's a siren call. They believe we're witnessing the early stages of a mass extinction, starting from the bottom of the food web and working its way up. But, like any good debate, there's another side to this story. The defense isn't made up of people who deny the crisis. Instead, they're scientists who are calling for caution and precision. For them, calling this a mass extinction is scientifically inaccurate and could, ironically, hurt conservation efforts. Their argument boils down to two things: definition and measurement. First, the definition. What actually is a mass extinction? The scientific consensus is the loss of at least 75% of all species in a geologically short period. And if we're being honest with the data we have, we are nowhere near 75%, not even close. While the extinctions we've caused are devastating, they don't yet match the sheer scale of the Big Five. But what about the rate of extinction, you might ask? That's the second pillar: measurement. How can we say we're losing species at an unprecedented rate if we don't even know how many species exist? This is one of the biggest, most frustrating questions in biology. Estimates range from 2 million to, get this, 3 trillion. A popular study suggests around 8 million species, but it admits that 80% of those haven't even been discovered yet. They're hypothetical. If 80% of what you're trying to measure is theoretical, how can you know how much you're losing? It is like trying to calculate the failure rate of businesses in a city without knowing how many businesses there are in the first place. Plus, extinction itself is a fuzzy concept. Sometimes species we thought were long gone suddenly reappear in a phenomenon known as the Lazarus effect. The giant Lord Howe stick insect, for example, was declared extinct in 1920. Then, in 2001, a tiny colony was found clinging to a remote volcanic rock. At the same time, countless other species have probably vanished before we ever knew they existed. This uncertainty makes it incredibly difficult to draw firm conclusions. It also matters what level of the evolutionary tree you look at. Losing a species is tragic, but losing a whole genus is far, far worse. Think of it like this. If species are the individual leaves on the tree of life, genera are the small branches they sprout from. If a leaf falls, it's a loss. But if you sever the entire branch, you lose all the leaves on it. And the unique evolutionary history that branch represents is gone forever. Genera are older and more distinct. So, losing them is a much stronger signal of a deep biodiversity collapse. And this is where the story takes a surprising and even hopeful turn. A recent study did just that. It looked at extinctions over the past 500 years, but focused on these higher levels, like genera. They found that while about 900 species have gone extinct, this only resulted in the loss of about 102 genera. That's less than 0.5% of all known genera. But here is the most shocking finding. The study discovered that the rate of both species and genera loss actually peaked about a century ago, in the late 19th and early 20th centuries. And since then, it has been declining. How is that possible? The answer is simple. Conservation works. The bans on whaling, the creation of national parks, habitat protection, removing invasive species from islands, captive breeding programs. All of these actions, while not nearly enough, have had a real, measurable impact. The decline in extinction rates over the last century is proof that our efforts are not in vain. So where does that leave us? Are we on the brink of a sixth mass extinction? The most accurate answer seems to be not yet. The scientists leading this new research don't deny the severity of the situation. They prefer to call it an extinction crisis. Why? Because the term is accurate. It reflects the moral urgency, but it doesn't overstate the science. To be the sixth mass extinction, it has to be comparable to the other five. And right now, the data doesn't show that. Using precise language is crucial for science to be credible. But a crisis is still a crisis. The moral urgency is still there. Every single one of those 900 extinctions was a tragedy that shouldn't have happened. We have a responsibility to prevent more. So perhaps the question isn't, are we in a mass extinction, but what are we doing about the extinction crisis? The story isn't just one of doom and gloom. It's also a story of hope. The data shows that our actions can make a tangible difference. Human action got us into this crisis, And it's only through more human action, through careful science and dedicated conservation, that we can secure a better future for all life on Earth. Thank you so much for watching. If you found this video interesting, please hit that like button and consider subscribing for more deep dives into the world of science. See you in the next one.